Good morning. Hey, I'm John Cruson from Sketch Development. Thanks for attending our webinar this morning. This morning we're talking about infrastructure as code, improving speed, savings, and security with Matt and Ryan. Matt and Ryan have a few words to say about themselves, so I'm going to let them take it away. Matt, Ryan, have at it.
Thanks, John.
Yep, thank you.
So good morning. I'm Matt House. This is Ryan Jensen. I'm an Agile coach here at Sketch Development.
And I'm a software developer here at Sketch. I'm also a cloud architect who likes to play around with infrastructure as code, which is what we're here to talk about today.
Yep. So before we dig into it, we want to open up Q&A. We're using Slido today to be able to do our Q&A. So if you want to go in there and get logged in now, you can. You can scan the QR code or go to slido.com and put in this room code. And you start putting in questions, and then you can upvote and downvote questions as they come along. And we'll bring this back up again at the end to add more questions. Okay, so as we said earlier, we're Matt and Ryan. And I like to still pretend like I'm a developer from time to time. Whereas Ryan's very methodical, and he likes to make sure everything's put together in the right way. And me, I play a little fast and loose with things. So we're going to kind of emulate those behaviors today. And I want to stand up a couple of environments. You guys have probably seen the advertisements. We're going to talk about putting together environments from scratch. So before we begin, I need names for my environments. So if anybody would like to throw into the chat what their starting Wordle word is, we're going to use that to help us create our environments.
We're hoping for some interactivity here.
Not everybody's had their coffee yet, I don't know.
Or maybe, there we go. Well, Dolphin's a few too many letters. There we go. Let's use that from the audience.
Radio
Arise.
and Arise.
Radio
Okay.
and Arise.
So I'm going to flip over to my terminal here. Should be.
Backspace. Slash create. Tab.
So I am going to run a script here. Let's see. Let's use radio for one.
Okay, go to the other tab. Clear that real fast.
And let's use Arise.
Give her that name.
Great. So I just kicked off some scripts that are going to go create us some environments, and we're going to check back on it in a little bit. So first, let's start talking about what your infrastructure looks like.
Okay, so now that Matt kicked that off, yeah, what we're here to talk about today is how infrastructure helps you with speed, savings, and security. But before we talk about these benefits, we need to make sure that everyone here knows what we mean by both infrastructure as well as infrastructure as code. When you hear infrastructure, what comes to mind? Is this infrastructure? Is this? How about this one? While it looks completely different from the previous two examples, this too is infrastructure. Infrastructure as code, that is. And this is what we're here to talk about today. So infrastructure as code is the process where hardware and environment configurations are created through scripted, repeatable processes. And then whatever might come to mind for you in terms of infrastructure, whether you're talking about servers, storage, DNS, networking things, any of that kind of infrastructure, that can typically be defined as infrastructure as code.
There we go. So with infrastructure as code, a user is able to, through a myriad of different tools, and be able to create and spin up infrastructure on a bunch of different platforms. Here we've got examples like Kubernetes, AWS, Google Cloud, Azure. or you've got the ability to be able to do this on-prem with other tools. And so it's not something that's just specific to the cloud. When we're talking about working in the cloud, it has a lot more options and gives you a lot more opportunities to be able to utilize infrastructure as code, but it is something that you can use in more of the traditional on-prem environment as well.
So to make our infrastructure as code, we need to start leveraging something that's called an infrastructure as code framework. And how do you get started building these things? Well, do you just say something like, Alexa, create me some infrastructure? Not exactly. You first need to create a template using some kind of infrastructure as code framework. Then you hand that template off to one of Alexa's drinking buddies to let them take care of it from there, which we'll see in just a moment. That's part of what Matt kicked off, and we'll dive in and see what happened from all that. But let's talk about some of these frameworks first. So in the world of infrastructure as code, there are cloud native tools, things like CloudFormation for AWS or Deployment Manager for Google Cloud. These are very specific to the environment in which you're deploying. But as Matt just said, there are other options that you can use to deploy your infrastructure to multiple environments, whether that be to different clouds. So something like Terraform, it's a very, very popular infrastructure as code framework that allows you to deploy to all three of the big cloud providers, to AWS, Google, Microsoft Azure, but it also allows you to deploy your infrastructure as code templates into an on-prem environment to spin up your infrastructure. There's also a newer framework that's really gaining a lot of traction in the industry. There's two of them actually. One's called CDK, it's Cloud Development Kit, and Pulumi. And the reason these two are gaining so much traction is, unlike the other two that I was just talking about, these cloud native ones, which typically use YAML or JSON as the template language that you'll use for creating your infrastructure as code, and Terraform, which is kind of like JSON, but it's its own language that you have to learn from scratch to figure out how to use it and implement it. The big difference here with things like CDK and Pulumi are they're programmed in languages that are already familiar with your development teams. So you can build your infrastructure using languages like Java, Python, C#, and Go, along with also JavaScript and TypeScript. But there's tons of more frameworks out there. We're not going to go into all these details. And what we've got here on this slide is just the tip of the iceberg down under more. But one thing I do want to call out under more is Helm. Helm is a great one also if you're deploying things to a Kubernetes environment. So I think that's one that we didn't really talk about. You've got your cloud providers, you got your on-prem, but Kubernetes is also a very popular platform that people deploy their applications to. And so actually Helm and Kustomize on this list are great tools to build your infrastructure as code and deploy to Kubernetes. So now that we've just talked about that, let's dig in and take a look at an example of some infrastructure as code templates to see how they get deployed. Watching this happen for real is going to shed a ton of light on the benefits of using infrastructure as code, which we'll discuss when we return from this demo.
So before we dig into it, let's just remember, the scenario that we started with. Ryan, the operations engineer, helped build all this infrastructure as code with guardrails in there so that Matt, the developer who knows enough to be dangerous, is able to utilize these templates and utilize the infrastructure as code that he built to be able to spin up an environment, but to be able to do so in a safe, secure manner.
So let's switch on over. So we're going to start by looking at the this Git repository first. And so this is something that we're sharing with everybody that's on the webinar here. It's a public repository. You can use this yourselves to both look at the templates that we're going to use here and learn from them, but it's also possible for you to launch this yourself. We're not giving you 100% of the secret sauce to make it work, but I think as you start to run it, the errors will be pretty obvious and you can make some changes, but it's really dependent upon the cloud environment that you're deploying to, which, by the way, the templates that we're going to use for this demo, they are using AWS CloudFormation, so it is that cloud native one only specific to AWS. So if you're using any other platform, the concepts still hold true, but you probably aren't going to be able to run this yourself unless if you have an AWS environment. So what I want to show in here is just real fast. There's a couple of scripts, and Matt triggered one that was kind of the one script to rule them all that kicked off a couple of these using those not the slide-do words, the Wordle words. And by using those scripts, we've got 3 infrastructure as code templates that are being implemented here under the covers for this demo. We've got one here that's primarily for the web tier of our application. We've got another one here for our API layer, and a third template that launches our database. So we're going to look at the web and database because they're pretty straightforward and simple to look at and understand. The API one's a little crazy, but we'll leave that to you to look at yourselves if you're interested. So looking through here, this is the web tier. And what's really nice about your infrastructure as code templates is oftentimes the provider that you're deploying to, whether it be Terraform or in this case, CloudFormation, there's a section for you to supply parameters. So you can have slight variations between your QA environment, your UAT environment, your production environment. But if we drill down a little more and look at how some of this looks, all of this is infrastructure as code. We're doing things in here like defining some storage. We've got some policies which are related to security. But this is a really neat one here that I want to call out. This is setting up an SSL certificate. Not a lot involved here for me to define what it is and get that in place for our demo environments. Let me scroll through a lot more. This is setting up a lot of web servers through here. But this one also is very much worth taking a quick peek at. This is our DNS entry. So not a lot required here to get the subdomains in place. So with our Wordles of the day, we had radio and arise. So this, in essence, is setting up a subdomain for radio.clifford.com, which we'll look at in just a second, and arise.clifford.com. So that's really all I want to look at this particular template. If we go back and take a quick peek at the database, this one's even shorter and simpler to look at and understand. But again, we've got parameters defined so we can separate a little variances between our different environments, whether it's QA, demo, or production. But in here, this is so straightforward. We've got some subnet definition defined right there. We've got some firewall settings right here. And then lastly, this is our database server. So really not a whole lot to it to get that up and running. So enough talk. Let's see what actually happens here with that. So I'm going to go to one of our Wordles of the day. So let's go with arise. That was a good one. So if we look at this, we can see the 3 stacks in here. So I'm logged into CloudFormation, which is an AWS service. And this is the provider that will take that template, the infrastructure as code template that we have defined, and it will parse it out and figure out what it is we're actually asking for, and it will go create those resources in the cloud for us. So we can see corresponding everything just froze. Mouse just locked up. Okay. So we can see all 3 stacks that are being launched here. We've got the front end, we've got the database, we've got the API, and you can see that some of them are already in progress. But what's really nice about this, if we drill in here and take a quick peek, we can see that some of those things that we were looking at in the template are also in here. So we've got things like our storage bucket. We've got lots of security and just custom resources. But as we go a little bit deeper, we can see that here's our SSL certificate. It's already been created. So this is still in progress. Let's go take a quick peek at the other one. I wonder if radio is any further done. So we can see that the front end for radio is done. And if we go open a new tab for that, let's go to radio.clifford.com, and you can do this yourselves at home. So this is a live environment that just got launched. I'm gonna make that hide. Thank you. So here we are at radio.clifford.com, and just to prove that this is not some crazy magic, we've got an SSL certificate that was spun up specifically for the radio platform. And later we can probably take a look, if you want, at the Arise platform once it's done and finished launching all of its stuff. it too is going to have a very unique environment. So with what Matt did a little bit earlier, he launched 2 commands, and with those 2 commands, we've got 2 environments that are being built out as we speak. We've got, like I said, the radios out there. We've got Arise, still in progress, but it's underway.
And it's important to note that in a lot of cases, when we think about infrastructure, we just think about the servers, and we think about the hardware, and we think about getting the application running, but we don't really think about all the other things that go into making an environment usable. Things like, as Ryan was pointing out, making sure we've got the right SSL certs, making sure we've got the right firewall ports opened up, making sure that the data is there. And a lot of times that I've gone to areas where we've got the software up and running, we're done. Well, no, we've got a lot of configuration to do for the environment, even things that are at the database level that we're going to have to configure. All of that was scripted in this case. And you can make all of these extra things that you need to be a part of your environment and make your environment functional, all a part of the script. So we actually had an export of the database loaded in there so that this is a fully functioning environment. And it's not, oh, we've got to wait and set up users, or we've got to wait and set up test data. All of that is now a part of the script that's able to get us up and running.
Yeah. So I think that's probably enough for the demo at the moment. Let's go back to the slides and let's start talking about some of the benefits, which hopefully, based on what you all just saw, it's starting to get a little more apparent what some of these benefits are. So the first one we're going to talk about is speed. We just saw how quickly and easily Matt and I launched a new environment. We got 2 environments up and running with just a one-liner command for each environment. Within your organization, are you spinning up new environments like this as well? Are you getting them done this quickly? But maybe we ought to talk about why you would even want a new environment in the first place. As trivial as it was, we just launched 2 environments. Let's call them demo environments. So we launched the radio and we launched Arise, 2 of those just being theoretical demo environments. So let's say perhaps within your organization, maybe your sales team wants a demo environment as well. One that's white labeled for some client to look at that you can really wow them and sell it to them when they see that environment with their own branding on it, with their own subdomain, client.clifford.com. Or maybe you only have a QA and production environment for your application, and you need to run load tests before deploying a new feature to production without impacting either of those existing environments. If you have some other reasons for a new environment, feel free to enter them into the Zoom chat, and we can talk about those too. But these are just 2 simple, probably more common scenarios that we know of where a new environment is needed. But now let's consider how long it would take you to get a new environment. So we're all on common ground, though. How about this for infrastructure? This is the infrastructure Matt and I just demoed. If you were to ask your infrastructure team to set up an environment similar to this, where you've got 4 servers, so we've got the 2 web servers, 2 API servers, there's 1 database server in the mix, 2 load balancers, some DNS that was created for those subdomains, and 2 SSL certs. 1 SSL cert for the API layer, 1 for the web layer to help protect communication and encrypt it between your end users and your application. Oh, and let's also not forget the fact that we had some firewall rules set up so that things like only the API layer can talk to the database, and the web servers can't. And things like the load balancer is the only thing that the web tier will listen to. So having all that in place, how long would it take you to get something like that going in your organization? Let's kick off a poll here and see if we get some answers from people on the Zoom call. So hopefully you guys are seeing the poll right now where we're asking how long it takes. Is it less than a day, 1 day to 2 weeks, 2 weeks to 3 months, 3 to 6 months, or more than 6 months? Get some answers? Cool.
Right. 1 day to 2 weeks for a couple people. That's really good.
That's awesome.
2 weeks to 3 months, 3 to 6 months.
Yeah, so we had a handful of people answer. Thank you for everyone who was participating. But yeah, it seems like some of you are already getting some of these fast returns and getting your environments launched, which is great. I'm probably assuming that you're using infrastructure as code, or perhaps if not that, maybe you're in a very heavy VM type environment where you can clone servers and replicate and things like that. Those are all great solutions, but we got a couple here that are taking a little longer than normal. And maybe if you guys aren't using infrastructure as code, this is hopefully something you can take back to your organization to show them how fast something like this can get stuff up and running. So let's move on and kind of equate that to some of the more traditional ways of launching infrastructure compared to doing this as infrastructure as code. So in the more traditional way, and as some of you answered, it's taking days to months to get a single new environment. But as you just saw, because we have these infrastructure as code templates in place, Matt was able to run the one-liner command from his console, and it launched 2 brand new environments that are getting up and running within a matter of 10 minutes. So the other thing that we want to talk about here, comparing more traditional way to the infrastructure as code way, is how stable are things? So is anything getting missed? As you're launching things in a more traditional way, maybe your QA and production environments are perfect, but for whatever reason, let's say you've got a UAT environment, and in that environment, it's not working quite right. For some reason, your API layer cannot talk to the database. How much time would you say is going to end up being wasted having your developers look into what's presumably an application issue just to eventually uncover that it's some sort of environmental or infrastructure issue? There's lots of rework and lots of time spent and wasted trying to troubleshoot these things that might have been caused by some fat fingering, as maybe your network or operations people are trying to manually get the infrastructure up and running. And on the flip side of that, with infrastructure as code, there's environment parity across the board. Because you've got this template in place, anytime you launch it, no matter how many environments you launch it to, each environment is going to be pretty much exactly a copy or replica of the next. So where else do we get speed from when we're leveraging infrastructure as code? Well, there's the whole concept of patches, updates, and upgrades. This is a pretty common scenario, and that would be where there's some need to upgrade to a new version of Java on all the servers across your application environment. Or, since we're talking about infrastructure in this webinar, maybe more appropriate, let's say there's a need for an actual infrastructure change, something like your app needs a second database in place to be used as a read replica. Or maybe you need some new IP addresses or ports whitelisted so that some new client or vendor that you've just brought on can access your application. All you have to do in these cases is make the change in your infrastructure as code template and redeploy. With just that one alteration, you'll get environment parity everywhere. As it's deployed, all those changes are fully flushed out throughout all places where you're launching that template. Very closely related to this concept is the testing of your infrastructure changes. If you change something in your template and test for the alteration pass, you can have very high confidence that when you promote your template to other environments, the changes are going to work there too. You can't just fat finger something by accident when you're using infrastructure as code in these other environments.
All right, so now I'm going to talk a little bit about where we see some of the savings by using infrastructure as code. Obviously, as Ryan just kind of illustrated, with all the speed and being able to spin up environments very quickly, as opposed to the manual tasks that we were normally doing, that we're definitely going to see lots of savings there. But there's other places where we're going to be able to see savings. So when we talk about decreased outages, everybody always talks about we have an outage, it's the big dumpster fire. Here, we're going to start putting out those dumpster fires. When you've got an outage, you're not only potentially losing functionality and losing revenue, present revenue, you might lose future revenue because people are going to be talking about it. Like there's nothing worse than having your outage blow up on Twitter. So when you've got these types of outages or we've got different types of disasters, we want to be able to recover from them quickly. And as opposed to having to spend all the time and effort in figuring out what's wrong on this server or what's wrong here, you could potentially just be able to kill off your entire server and bring it back up with a known configuration that you know is working. So you'd be able to recover from these outages significantly faster. If you had an outage in one data center and you needed to flip over to another one, being able to completely rebuild your environment with the snap of a finger is going to be incredibly helpful for you to be able to get back up and running. It's also really important when it comes to scaling. When I work in a lot of traditional environments, it might be, oh, we've maxed out the capacity on this server, so we're going to need to go spin up a couple new Tomcat servers and start being able to split up our capacity across those. Well, getting those servers requisitioned, getting those servers configured, and getting everything up and running takes time. Here, we can be able to snap of our fingers, be able to get these new environments up and running for when we need to vertically scale and need to be able to get whole new environments, like you don't have a pre-production environment or you don't have a load testing environment, need a new one, or you need to horizontally scale and I need several copies of this exact same server so that I can take on more traffic. And it's also important that you've got the ability now to scale down. Because you didn't invest a lot of time in standing something up, it doesn't hurt you as much when you're going to take the time to take that back down. When we talk about finding different problems, we want to be able to find any of those issues as early as possible. When we talk about like patches and upgrades and updates, Ryan earlier talked about environment parity and taking things up through like a dev, test, and production environment. I can't tell you how many times I've been in an environment where there has been a change made to our infrastructure that's maybe only been made at the production level and nobody knew what happened. And it'll take us hours to find out somebody changed permissions on a directory or something that trivial can take our entire environment out of the water. When we do these things now, we're able to do these things, and Ryan's going to talk in a little bit about checking these things in as code, that now we've got a full auditability. We've got full auditability, and we can see as things have been promoted to the higher environments, whether it caused any problems. And we can see here on this chart here, this is for normal app dev. And honestly, I think that these numbers might be even more inflated when we're talking about infrastructure and operations, and that the earlier we find a problem and we can sniff it out and correct it, the much better off we're going to be. When we have these issues in production, there's a much bigger difference between having a production bug versus having your system going down. So by being able to have all these things as infrastructure as code, we're able to test these things much earlier and validate whether they're going to cause us problems or not. This also opens us up to the possibility of blue-green deployments. I know a lot of organizations don't really practice the concept of blue-green deployments because it's not cheap. In order to do this, you've got to be able to have two different environments that are set up at the exact same levels with the exact same hardware and the exact same architecture to be able to have your traffic route from one to another as you're doing an upgrade. And that can become very expensive. As infrastructure as code, now environments can come up and come down on a whim. It becomes significantly more affordable. And it opens up the door for you to be able to do zero downtime deployments. As opposed to doing your deployment at 2 in the morning when you don't have any traffic, you can now be able to spin up a second environment in the middle of the day over lunch, start routing traffic to that new environment, and have a zero downtime deployment for your customers to have no impact. And this is also going to open up the door for you to have faster and simpler rollbacks. If issues are found, we can now roll back and start routing traffic back to another environment or a known configuration that we knew worked. And so, like I said, we talked about the value of being able to spin something up, but there's also huge savings in being able to bring something back down. We're talking about being in a cloud environment. Well, it doesn't really matter that we take it up and take it down. It's now that when I take it back down, I can see savings from having it down. So let's think about a whole different paradigm shift where instead of having a long-lived dev environment that you've got up and running in your data center 24/7, that everybody has to be in at the same time, people are stepping on each other's toes, it's probably just as cost effective to say, we're not going to have a shared dev environment out there. It's going to be totally ephemeral. And when a developer needs to test something, they can spin up their own environment. And when they're done, they can tear it back down. So with that, I'm going to tear down these environments because I don't feel attached to them. It's not like we invested a lot of time. What was it again? Tear down? Delete.
Yeah. Let's do pre-baked, pre-baked. So we've got an environment out there called prebaked.clifford.com. And so while this is running, I do want to, we're going to dive back into the CloudFormation environment here. But first, so as you can see, we're logged into this particular demo environment. So this is prebaked.clifford.com. And I can refresh this page and all of a sudden things aren't working. And that's as to be expected, because if we go look back at CloudFormation, pre-baked, I think I hit space. So we can see that this environment is currently being deleted. And what's really, really, really nice about infrastructure as code is when you launch these stacks, each stack knows exactly which infrastructure resources are tied to it. We were looking at this a little bit earlier. This particular front end stack, these are the 9 resources tied to it. So when I, or in this case, Matt, trigger a deletion of it, all of these and only these are the ones that are going to get removed. So if we've got 40 different demo environments out there, and this is the one we want removed, we pick this stack, and because it was all defined within this template, it equates to this stack. We know these are the resources being deleted. And we can see some have already been removed, delete's complete, there's a couple delete in progress, and that's why when I did this refresh on prebaked.clifford.com, it's just not working anymore. And it's going to keep getting worse and worse as more and more things are getting, pulled out from underneath us, which is what we asked it to do.
Okay, so now we're going to transition back to Ryan to talk to us about how infrastructure as code can give us better safety and security in our environments.
Yes, get over here. Thanks. Okay, so this is the last topic we're going to talk about in terms of infrastructure as code benefits, and that being security. So, blue screen of death. I think we've all witnessed this before. We've all seen it. It's usually a sign that you're in for a bad day, but what do you do to get around this? What do we do here? The answer is typically you just reboot your computer. Similarly, if you've got an internet issue and you call the cable company, they have it as part of their pre-recorded message now because it's cheaper than having every single customer service rep tell you that you just need to unplug and replug your modem and router, reboot. So Matt and I just showed you how easy it was to tear down this environment. Not only was it easy to spin up, but it's almost equally easy to tear down when you're using infrastructure as code. Not only are there cost savings associated with that by having the environment not be there anymore, there are also major security benefits. Tearing down a whole environment is super easy thanks to these templates and the collection that you get when you're using the stacks like I was just showing you. When we tear it down, if any bad guys found their way onto any of your servers, installed something like whether it be a virus, a Trojan horse, a packet sniffer, or even a backdoor that they could use to later get back onto your servers, that's all gone when you tear down that environment. When you relaunch your environment using these infrastructure as code templates, none of that bad stuff returns. Now, there's still the issue of how they got on there in the first place, but the activities conducted by them are mitigated thanks to an IAC refresh. Now, this whole concept might not be a great solution for your production environment. You definitely don't want to scrap your whole app and prevent your users from being able to place orders and generate revenue for you. So this next part, it's a little tangential to infrastructure as code, but it is worth mentioning. Primarily because it is a solution that you can use for those production environments. Instead of defining each individual server in your infrastructure as code template, you can leverage provider-specific resources, things like Kubernetes deployments or AWS auto-scaling groups, just to name 2 of them. These can be a solution allowing you to willy-nilly kill servers, even in production, allowing for new ones to come and take their spot and be bad guy free. In fact, I just attended an AWS partner training about 3 weeks ago, and in it, they recommend this exact scenario when using Kubernetes. They talked about setting up a scheduled job that will terminate your pods every 5 or so minutes, thus increasing your security stance. So it is something that is out there in the industry. It sounds a little weird to be just willy-nilly killing your servers, especially in production, but it does add a whole lot of security to your overall environment. And speaking of infrastructure refreshes, let's talk now about a similar topic, immutable infrastructure. The exact definition of this is infrastructure cannot be changed, but rather replaced. We're going to talk about it a little more loosely, however, focusing on the fact that humans cannot change infrastructure. Consider this scenario. Your operations team and anyone else within your organization, they only have the ability to look at and examine your infrastructure resources. They cannot create or modify any infrastructure themselves. Obviously, though, changes need to happen. So you set up automation through a CI/CD pipeline. And for anyone not familiar with what that is, Matt and I hosted a webinar a few months ago on this topic that you can find on Sketch's website. The pipeline, though, can be granted access to do things like create, update, and delete the infrastructure resources. This then forces any alterations in your environment to be performed via modifications to your infrastructure as code templates. What this brings us is a form of GitOps. It's a recent advancement in the world of IT strategies. That's a topic outside this particular discussion, but we encourage you to do some further research on it yourselves. But by following this core principle of GitOps, where humans are prevented from making direct changes to your infrastructure, and changes are then forced to happen through IAC, you can enhance your security through source control. Now, source control is one thing software developers are already very familiar with, and perhaps some of you on this call are too. By doing infrastructure as code, emphasis on code, you can now take advantage of source control for your infrastructure. Here's an example of change history. One of the features and benefits of using source control. It tracks who changed something and when they changed it. You might even get the why they changed it if they were verbose enough with the comments that they added to the changes when they committed it into source control. Additionally, you can drill in to see exactly what was changed. You can see what the values were and what they were changed to. And then there's the whole peer reviews concept. Often compliance such as SOC compliance or PCI, and sometimes even HIPAA, requires multiple reviewers to look at things before applying and deploying these changes. This type of configuration can be implemented within source control as well. All of this, all three of these things combined, the seeing who changed it, when they changed it, what they changed, and having these peer reviews add a lot of compliance and auditability to your infrastructure environments that maybe you didn't have before. If people were just cloning VMs left and right, or manually logging on to firewalls and adding, opening up different ports and adding IP addresses. A lot of this is now auditable and therefore helps keep you and your organization safer in terms of security.
All right. So to kind of wrap things up, let's summarize what we did. We did it all. We talked about, we asked in the poll how long it takes you guys to get a new environment, and even in the best case scenario, it was still a couple of weeks. Well, just in the time we've been doing this webinar, we have stood up 2 environments. We've torn one down. We validated the environment. We've done it quickly, and we're comfortable that it's got the right security on there. We know that we're not having any issues with it. And when we were done with it, we shut it down, and that's actually saving Sketch money. So you're welcome, John. And best of all, we did it without needing to submit a ticket. This is a really important thing, because even when we go to organizations where they've got like cloud enablement teams that are able to help people get environments spun up as quickly as possible, it still requires a ticket to be put in. So as Matt, the developer, I'm going to still sit around and wait because I don't get access to those types of things. But this is what usually we find is holding organizations back. When we look at why organizations haven't adopted these principles to be able to do the things like Ryan and I just demonstrated, a lot of it comes down to the insufficient alignment and collaboration between the different functions of the organization. So a lot of cases, everything is siloed. And so as Matt, the developer, and Ryan, the ops engineer, we don't talk a whole lot. We don't work together a whole lot. This has to be a collaboration in order to be able to get this so that we don't get stuck in the mud. We find an insufficient investment in the technical processes. So Ryan didn't just do this right before the webinar. Ryan spent a bunch of time putting together these templates and putting together the guardrails that would allow me to do this safely. And that's the important thing, is we want to enable our development organizations to be able to utilize these types of patterns and paradigms, but we want to be able to do it in a manner that we know is safe. Ryan still stood it up with the right encryption, with the right sizing for when it comes to, he wasn't going to let me spin up an M5 metal server that would cost the company a bunch of money. All those guardrails were baked in, but I still had the freedom to create an environment that I would be able to use and be able to test it. We also see a lack of dedicated time investment in being able to build these patterns. So if we want to be able to do this, your team's going to require time. I still walk into a lot of organizations where teams are stuck in firefighting mode all the time, and we can never get the time investment in order to build these types of patterns out, so that now your operations organization can really be that enabler for your development organizations, and you can get that much tighter alignment. So here at Sketch, if this is something that you're struggling with in your organization, this is something that we can help with. This is something that, when it comes to their ability to be able to do technical coaching in your area, we can help get these things put in place. We can definitely help get teams put together to be able to help build these things, so that you're able to accelerate where you guys are as an organization, and be able to kind of move to these paradigms. So with the flip of a switch, you guys can start spinning up your own environments, be able to do whatever testing you need to, and get rid of them when you don't need them. So with that, let's open it up for questions.
One more.
Oh.
So anybody that might have joined a little late or missed the first slide, we're doing the Q&A on Slido, and you can either go to slido.com and enter in this this code, whatever, or you can scan it with your phone, scan the QR code, and it'll take you straight there. And feel free to add any questions that you want. We've got one here at the moment, so let's just leave the Slido up while we take a look at this first question. So we've got a question from Todd. Todd asked, how does this fit into a traditional data center? So I know our demo was definitely geared towards cloud and specifically AWS, but we were talking about the different types of infrastructure as code frameworks that exist out there. There are things like Ansible, and probably more prominently is Terraform. Terraform is a great infrastructure as code framework that allows deployments not only to the cloud, but also to an on-prem environment. So that's theoretically your traditional data center. All the concepts we talked about, though, the speed, the savings, the security, hopefully that all makes sense. I can do a quick summary of it, but all of those still apply regardless of where you're deploying to, if you're using infrastructure as code. So even with an on-prem or traditional data center, you still have that speed of, I launch my template and I've got a plethora of servers out there and load balancers and firewalls all set up between them. You've got things like cost savings. Unlike the cloud, where when you tear an environment down, you're saving money, that's one thing you're not going to get with an on-prem or traditional data center. But you should realize lots of cost savings just from that speed by not having an ops person spend weeks to months to get all the servers required for another demo environment or another testing environment or load balancing environment, whatever the case may be. So through that speed, you're going to see savings, not just from the ops engineer that had to create all the infrastructure, but from your dev teams that would typically have to wait that duration to get that environment up and running. So now your whole organization has this new environment for whatever purpose it might be. They can use it right away and start to figure out what those returns on investments are for adding the new features that require the new environment for the testing purposes. And then security, I think that holds true no matter what you're doing. If you have that ability to scrap and rebuild the environments, well, I was gonna say traditional data center, I was assuming all traffic was in-house, but that's not true. And regardless if you've got bad actors within your organization or bad guys in the outside world trying to hack that environment, you can still leverage the concept of the system refreshes, but also everything that comes with source control. If you're doing your infrastructure changes and committing that back to source control, you've got all that auditability. I hate that word. I always trip over it. Got the auditability, so you can see who changed the infrastructure, why they changed it, when they changed it, what they changed. So it's great. I think all of these things apply regardless of what infrastructure as code framework you are using, and regardless of where you're deploying to. Again, to the cloud, to Kubernetes, to on-prem, all of this still holds true.
One of the other advantages you can get when you're working in kind of more of a traditional data center is the ability to move your workloads from machine to machine. I've had times where I've been working in Kubernetes and I've been able to, I needed to do server maintenance on one of my servers. It wasn't as easy as being able to spin it up and spin it down, the whole server like you could do in EC2, but I was able to move all of my production traffic from one box to another box seamlessly because everything was spinning up as infrastructure as code, so that I could take that server down, do maintenance on it, bring it back up, and move the workloads to it seamlessly without any of my users noticing any sort of a difference.
Okay, we've got another question on Slido from Rick. The question is, does this put requirements on my architecture?
To a degree. I mean, if you're gonna get the best out of this, you're going to have to potentially architect your applications a little bit differently. They've got to be able to. I've seen organizations try to do this. They've put stuff into containers. Then we try to spin things up and spin things down, and maybe their application's a little more sticky, and it has problems with sessions being able to come up and down. So you might have to architect your applications a little bit differently to live in an environment where they can more freely come up and come down.
Yeah, I definitely agree. I think you can still do and mimic a lot of traditional architectures. So in certain cases, it doesn't require it, but I would definitely suggest if you are deploying things to the cloud and leveraging infrastructure as code, that you look for more cloud native type solutions. So I think in our example, we were showing diagrams and whatnot that more closely mimic traditional infrastructure. Things like it was on the GitHub. Can you direct to GitHub over here real fast? Let's go back a couple. Let's go to, IC webinar. So in this diagram here, this isn't actually exactly what was deployed. We did deploy some more cloud native type resources, but depicted them here in a more traditional way. So if you are trying to modernize things, there are ways that instead of actual web servers that we've got on this diagram, we leveraged an AWS native service called CloudFront, which is a content delivery network that it manages all the loading and scaling and balancing and everything for serving up the UI content. So I think if you already have some applications out there that you haven't done infrastructure as code for previously, you don't necessarily want to backtrack and redo that, but maybe think forward and how can you modernize your applications? How can you take advantage of some of these maybe cloud native services that also have corresponding infrastructure as code implementations as well? That's definitely something that you can leverage, and that would be a change in architecture, but you're going to see lots of other benefits when you use, if you're going to the cloud and if you're going to use some of the cloud native services. Okay, I think that's it in terms of questions. I see Todd also mentioned in the chat, I think it was the same question that was out there on Slido, but he does say that it was a loaded question, so I'm kind of curious. Hopefully we answered what you were hoping to get out of that, Todd. If not, feel free to either add something back to the Slido or talk to us again here in the chat, in the Zoom chat. Otherwise, that's it for questions.
Any other questions? I know we hit you with a fire hose of information today, and we kind of showed you some things that if you're not experienced with it, I remember the first time, I was seeing some of these things the first time, it felt like black magic and voodoo. Because I remember, oh, we need a pre-prod environment. I was with an organization where they jokingly referred to the pre-prod environment as the chupacabra because it was frequently talked about but seldom seen. It was taking years to get an integrated environment up across the enterprise for all the systems to be able to talk to each other. So when I saw something like this for the first time, where at the snap of a finger, a whole environment was stood up, including all the back-end data, I was totally blown away with it.
Okay, well, we're going to leave the Slido open. So if anybody comes up with any questions or in the middle of typing, feel free to submit them on Slido and we can address them later. We'll contact you via email or something, but it's great having everybody attend. Thank you very much. And I think we did it.
Yeah. Have a great day.